Hello everyone. In this video I just want to make people aware of a useful resource for plotting polar graphs. This resource is also freely available on the web. You just sign up for it. It won't cost you anything. It's called Geogebra. It can be found at this first link, which I'll include in the description below the video. And then the applet I'm going to use today can be found at this link or this one. So I'll probably just use this one at the moment. And what I'm going to do as an example is I'm going to look at the relativistic orbit shape equation. And we know that in general relativity, orbits of objects, planets, stars, whatever, precess in their orbit. It's one of the orbit of Mercury is one of the earliest supporting bit of evidence for general relativity, how it precessed. And so what I'm going to do is plot this in the polar grapher. And this video is a partial answer to a question I've been asked by a viewer who wanted to have a look at an example on how to plot some of the different orbits we get, from the glancing orbits to the hyperbolic ones to the bound orbits and so on. So what I wanted to do is just show you this free resource, which is it can do much more besides just plot polar graphs, but I'm just going to pick polar graphs for today. Okay, so let's have a look. We'll go back now. It's that first link, and then I'll go on to the second one, and we'll have a look at how to use it. So let's go there now, and here we are. In the first one, if you go there, you'll end up with this. If you click on that, it will take you to GeoGebra itself, and you can have a look at signing up and doing different things. Now if I pick the second link or the third one, I'll pick the second one, either one will take the same thing. You come to this graph here, and what I'm going to do is make that my full screen. And what I think I want to do is that point A and the point PT, I don't really need that, so I'm going to get rid of that, and I'll get rid of that. I don't need to display that. And I'll keep this A value because what it's really talking about is the angle through which you turn. So I can turn that to, if I go down here, I might turn it to pi. Let's pick this one again. Might turn it to pi. I don't want 13 pi, not yet anyway. So I'll take pi. Now, if I just plot the sine of the 1 plus 2 sine t on 2, that's what I get. What I'm going to do is change the plot to what I showed you earlier from the relativistic shape equation, this one, and I'm going to have 0.85 times cos, and I'm going to now put parentheses there, and I should be looking for, hopefully theta is one. Yes, that's the one. Did I get that? Here, I need to look here. My apologies. There it is. Come on. Don't be slow. Don't be shy. Oh, is it being difficult now? So, okay, well, what if I put t there? Okay. And what I'll do is 0.8, whoops, 85. I was able to get theta in there before, but it doesn't matter. I'll use t, I'm really not worried. Enter. Okay. Now, okay, so that's moving it through pi. I'm going to change a now. What I think I will have is 2 pi. Enter. There you go. Now, here's a complete orbit, but notice the orbit, as we expect in general relativity, doesn't close up. Now, I can just click on the screen. Yeah, just zoom out a bit. Notice the orbit doesn't close up as we expect. Okay, now what happens if I change that now to 3 pi? Okay, let's change it now to 4 pi. So 2 complete cycles. Okay, and enter it again. Oh, whoops, I need to move. What happened there? I shall have 4. And let me put in pi. 4 pi, enter, there we go. That's better. I might just zoom out again. Okay, so there's 2 complete cycles. Again, it doesn't close up. So what I'm going to do now is I'll go a little bit further and let's make that 6 pi. There we go. Let's make that, see the actions happening up here. Let's make that 8 pi. Okay, keep going. I might make it, I don't know, 16 pi. Okay, anyway, you can keep making it as large as you like. You can keep going this way around, but you can see it's probably getting a bit messy, so maybe I won't do as many. Maybe 10 pi, even though it's looking a bit messy. Maybe I'll make it 8 for 4 revolutions. Okay, and the screen's still filling up a bit. Maybe 3 revolutions might be better. Yeah. Okay, there you go. So you can see 3 revolutions. You can do it bit by bit. Okay, but you can plot these. You can download it. So what I'm going to do now, what would be handy is I'm going to, where is the, under the grid selection, I'm going to put in the polar grid there. Okay, you're also free to label. You can put that in or take it out. You could have nothing. Do it like that. Nothing. Put a grid in there if you like. Polar grid there, as I did in that video number 11 in Schwarzschild series. You can see that you've got the bit there. Now, more than that, we can label our axes. That comes in here. We can set our grid, polar, distance. Set it as much as you like that. It's up to you. Do you want to go by pies? Theta. Do you want to set it pi on 6 perhaps? Maybe pi on 12. It's up to you. Bold. Whatever. Change the color. Make it black. Okay. Oh, I made it red, didn't I? Of course. How's that? Oh, that go a bit. Oh, okay. That's all right. What else can I do? Okay, I've got that now. I can label the axis too. Label it whatever you want. Put some other letter in there, Greek letter, what have you. It's up to you what you want to do. Yeah, whatever you want to do. However you want to label it. Same thing with the y-axis. Basic stuff there. You can set the ratio. Depends on what sort of plot you're doing. Various things apply for polar, not for this. If I come back to the grid now, maybe bold is a bit strong. Line style, I can change that. Oh no, that wasn't very good. I'll go back to what I had before. Grid type, basic line style. Okay, putting arrows on the end there. Not that that's really necessary. Just leave it like that. So various things you've got options of playing with. Okay, remove that now. We're back to our plot again, and I can mark the origin. If I don't, the beauty is that I can change that to as many revolutions as I like. So I make it 9, for instance, goes like that. And now then the thing after that is what I can do is I can then, with this, is I can download this. All right, I can download it as Geogebra file to use again. Various image formats, PDF and so on, which is useful if you want to put it into different documents and so on, or simply if you just want to download the Geogebra file itself and use it later on. Okay, so that's just polar graphing and different things you can do there. You go up here, and in this cursor places where you place your command line there. This gives you all the letters there. I don't know why. Oh, okay, so it wants to play now. I can get theta. All right. So same thing, I could use theta or t there, it really doesn't matter. It says r of t, so it made sense to use r of t, but yes, I just like putting theta in there. So what you do is you change that over here, and we're going to put theta there. Will it like that? No, well, it's saying it's dependent on t, so I think, no, I think I should have put a t in there actually, right from the beginning. But anyway, let me change that to a t. Alright, so it's a handy producing nice graphs for you. You can label the axes. Just a matter of finding where you could put an axis. You could put a label here, and let's say you might want to put a few things. So you might want, I don't know, in units of, I don't know, GM. C squared. So in units like that. Okay, you might want to do that kind of thing. It depends on how you want to do it, but I might have had xc squared on GM, whatever, however you want to scale your units. There's a lot of things you can change. Okay, I think it's a great device. You can certainly, you could print the screen to, like when I make my videos, I can just print the screen to Paint or something like that and then copy it into PowerPoint, but you can certainly download these, and it was just a matter of not going to that one, sorry, it's going up here. Save it, export the image, download as, depends on what you want to do. There's a lot of different options. We can rescale it simply by touching on the screen, and like many programs, you can just in and out. You can change it elsewhere. Just be aware for the polar plots, what is the angle you want to turn to, and that's the A value here. So you go to this one. Don't remove that, otherwise how are you going to plot anything? So what you want to do is include that. So if I change that to, I don't know, 14 pi, it will work, but that caught me a bit by surprise. But anyway, so I'll leave that up there, because you can, when you do that, with the A, that allows you to put the slider, that's right, yeah, that allows you to put the slider in here, and you can slide it forward like that, and there you go. You could film your screen as you do that. And probably in hindsight, if I were making that Schwarzschild 11 video again, using the slider here, just controlling it like that, is very actually handy. I might have included that, so I might just, yeah, I might. It's a little bit cut off at the top of the screen there, but still, I might be encouraged to have done that again, just for showing these purposes. Anyway, that's it. There's a program, so I'll upload this video shortly. It's free software, so I think it's really handy for a lot of things. It does many other things besides. I've just given you one snapshot of one function, but it does so much more: graphing, geometry. It's a wonderful educational tool. Okay, there you go.